everyone. Thanks for joining us. Welcome to another episode of the Apache TinkerPop Contributorcast. Today we're going to be talking about the recent release of TinkerPop 4.0.0 Beta 1. So this is the first beta towards the release of TinkerPop 4. Joining me today again is Ken and Yang, and we also have Andrew, our new contributor. So thanks for joining me, everyone, and let's get right into it. So as an overview of what we'll be talking about today, first we'll just break down what's actually included in Beta 1, and then we're going to get into some of the details on some of the design and work that's gone into TinkerPop 4 so far. One of the main themes of TinkerPop 4 is trying to simplify Gremlin execution. So a consistent problem we had with TinkerPop 3 is there are so many different ways that Gremlin can execute, so many different paths it can go down. So there's choices between WebSockets and HTTP, there's choices between scripts and bytecode. Within those, there's more branches you can get down. You have different serializers, you've got the different op processors, different script types. So we really want to cut that down and just standardize on as few paths as possible. This should simplify providers because there's less that needs to be supported. It should simplify things for users because they should have less choices they need to make, and they shouldn't have so many issues where some examples don't apply in all cases because it's for a slightly different setup. So that's sort of our main overall goal, and in that light, we've decided to promote HTTP over WebSockets as our main protocol, and we've promoted scripts over bytecode as the main way of sending Gremlin. And with those changes, that's prompted some new work with our serializers, and it's also led to some changes to Gremlin Lang and Gremlin console. So that's what we'll be talking about today. To start off, just what's in Beta 1. The main focus here is we want to give users an opportunity to try out the new changes, the new HTTP-based server. And so far, the Java driver and Python drivers have been rewritten for HTTP. So those are what's included right now. There's also the standard embedded stuff. Tinkergraph is there. All the Gremlin core stuff is there. But this is really to give users an opportunity to try out the new drivers before all the other GLVs are converted to HTTP. And with that, I'll pass it over to Ken to talk about the choice to promote HTTP over WebSockets.
Thanks, Cole. So yeah, as Cole mentioned, HTTP is the only communication protocol that's used in Beta 1. You may be wondering why we chose to switch to HTTP instead of from WebSockets, or instead of supporting both. So supporting both would be a maintenance burden. I've tested a little, and for most TinkerPop usages, there's only a very small performance advantage to using WebSockets. HTTP is also just more widely used. So you'll just have a lot easier time integrating with other products like proxies or just other middleware. And there's also a lot of other tools that take advantage of HTTP as well. So you'll just have a much easier time integrating with those types of products. If we move to the next slide, please. So in regards to HTTP API, the 3.7 server already supported HTTP in some capacity. There was a sort of HTTP channelizer but it wasn't turned on by default. But the implementation in this beta is sort of very different from what was there already in 3.7. So the 3.7 implementation, one of the biggest problems with it is sort of how it processed the queries. So it held the entire response in memory until it was completely done, and then it sent the response back. It didn't support streaming. So this probably led to a lot of sort of out of memory issues and things like that. With Beta 1, we now support HTTP streaming. So because right now we only support HTTP 1.1, a lot of that's just going to be done through the sort of the transfer encoding chunked mechanism, the HTTP 1.1 streaming mechanism, essentially. So we've also updated the API, the HTTP API in this Beta 1. I refer to it as the TinkerPop for HTTP API. It's very similar to the previous sort of HTTP and WebSocket APIs, but has some simplifications. So if you take a look at the slide there, the left is sort of a reference of what each request can contain, and the right is what an actual request, like an actual HTTP request would look like. So you might notice that some of those arguments from the request body have been removed, like the args. That's because the entire op processor infrastructure has been removed, since that was largely unused. Some of the information that was also in the body has been moved to the headers to better match some of the HTTP semantics. So that would be things like the user agent. As I mentioned before, due to the removal of the op processor API, if you're a provider and you want to extend the server, your choice now is really just to either implement or extend a channelizer yourself. So should a provider do something like that and extend the server, we've added some additional capability for the Java driver and Python driver, the GLVs, to sort of interact with the server in that way. So we've essentially changed how the request interceptors work. I should warn you that the request interceptors are an advanced feature that should be kind of used only when you really need to. And that's because the order matters in the interceptors. They get sort of processed in order, and there's other features inside the drivers that are request interceptors, like the whole auth mechanism now is built on top of these request interceptors. So if these aren't placed in the exact right positions, you might just break some of the other features in the drivers. Another thing to note is that the request interceptors only allow you to change the request, but not the response. So the response always has to be something that is that was serialized with either GraphSon or graph binary. For the drivers in the full release, that will be graph binary only. And the other thing I kind of briefly touched on there is auth. So with the move to HTTP, we've gotten rid of the SASL auth mechanism. You can only use basic HTTP auth for now. When we move to HTTP 2, I think that's a future plan, is to support both HTTP 1.1 and HTTP 2. At least that's what I said on the dev list. We might add the support for SASL back at that point. But as of right now, there's only support for basic auth. And now I'll hand it off to Andrea to talk about the Java connection pool.
Hi, everyone. My name's Andrea. I'm a new contributor to TinkerPop. And before the holidays, as part of the WebSockets to HTTP conversion, I converted the Java driver connection pooling to be more suitable for the short-lived HTTP connections, as opposed to the longer-lived WebSocket connections. So now it's faster to create new connections, and instead of initializing a pool with multiple connections, it's initialized with a single connection that's used to validate the configured host. The min size setting has been removed, and the max size default has been increased from 8 to 128. And I also added idle connection cleanup after a default of 3 minutes, which is also configurable. And now I'll hand it back to Ken.
Thanks. So the serializers, with the sort of change in format that I talked about earlier in sort of the request message, the message serializers also needed updates. So this beta version introduces GraphSon v4 and graph binary v4. So although the beta drivers have support for GraphSon v4, this won't be the case in the full release. The GLVs will only support graph binary then. This is sort of like a testing debugging feature that exists in the beta version for now. So that's something to keep in mind. And Another thing to keep in mind is that graph binary v4 and graphson v4 are the only message serializers that are going to be supported out of the box. This really means you can't use things like graphson 3 or graph binary 1. Those won't come with the server. So you'll only be able to use graphson 4 and graph binary 4. And a little more about graph binary itself. So the format is very similar to graph binary 1. One of the most notable differences is going to be the change in type support. So a lot, if you looked at the list of supported types before in graph binary v1, a lot of those were sort of JVM types, like all the java.time classes in that package were supported. And they're all very quite similar. And there's also a lot of things that couldn't be returned in traversals, like a lot of the enums. So there was a lot of sort of bloat in the types that were supported. And a lot of that has sort of just been slimmed down a little bit. The unused types, redundant types, a lot of those have sort of been removed. I think the biggest change is going to be how custom types work now. So the whole registry mechanism and that is going to be replaced by something that is being called provider defined type, or PET. I'll hand it back to Andrea so she can explain a little more about that.
So TinkerPop 3 allows providers to use what we call customized types, but they require both the server and the driver to register the type in a serializer registry. Failing to register the type can cause serialization errors. So if a provider wants to start using a new custom type, but the driver hasn't yet registered it, the driver will experience serialization errors whenever they receive a response that has the new custom type. So for TinkerPop 4, we are wanting to improve this experience by replacing custom types with what we call provider-defined types. Provider-defined types we are looking to support customized types with minimal configuration. And the intent is for the PDTs to be serialized as a map of fields and values. And the driver will be able to detect a PDT in the server response and deserialize the data into a map of key value pairs without any additional configuration. An annotation-based POC of the concept will be posted to the dev mailing list in the near future. And now I'm going to hand it off to Yang.
Okay, thank you, Andrea. Yeah, so as discussed previously on the dev list, so now all the requests are now script-based. So the graph traversals in the GLVs, they now construct scripts instead of bytecode to send remotely. So one of the purpose that bytecode served was to provide a universal way to translate a traversal. With the introduction of the Gremlin lang parser, this need can be fulfilled differently. So any Gremlin script can be converted into a traversal in a uniform way, which does reduce the need for kind of having both a system in. So because they serve a similar purpose and then to reduce the complexity, so we've have removed bytecode. So another consequence, or rather change, is just that we're now defaulting to use grammar-based Gremlin lang syntax. So this means that when graph traversal is constructed into string scripts, now they now follow the Gremlin lang syntax. So some types there's a slight change from the old Groovy syntax. So you notice something like big decimal, they have a slightly different syntax. So that would imply that for traversals involving these types, only the Gremlin script engine can parse them. And this does lead us to our next topic, which I will hand over to Cole to talk about updates to the Gremlin lang language.
All right, thanks, Yang. Yeah, and there's really three main changes I want to highlight for Gremlin language updates in the TinkerPop 4. First one here is the new translator infrastructure. So in TinkerPop 3, there was really two types of translators that existed. There were, in every GLV, there was a translator that would convert from bytecode into a Gremlin Groovy script. And then there was in Gremlin core, we had translators that could convert Groovy scripts into any of the different language variants, be that Python, .NET, Go, whatever you'd like. So it always round-tripped through Groovy scripts. Obviously with TinkerPop 4, now that we're not sending bytecode, we're always sending Gremlin Lang scripts. The graph traversal into script format that just happens automatically. So all the GLV translators are now gone. In its place, you can just directly extract the new Gremlin Lang script from your graph traversal in your GLV. And to go along with the promotion of Gremlin Lang syntax over Gremlin Groovy, there's also a new suite of translator series that utilize the Antler grammar to translate from Gremlin Lang scripts into your Gremlin language variant of choice, yeah, Python, Go, what have you. So now there's just one interface for that script to language variant translation. You can just use it to convert all your scripts to the variant of your choice. So that's just simplified, streamlined interface, should help new users. The next change I want to highlight here is about variables or parameters. So Gremlin Groovy has always supported parameterization, right? That's just something that it inherently got through Groovy. Up until very recently, Gremlin Lang has not supported parameters. That was changed in 3.7. There was some support for parameters in Gremlin Lang, but with the adoption of scripts over bytecode now that we're constructing scripts via graph traversals, we needed a new piece of syntax to actually instruct the graph traversal that a certain value should be parameterized. So with that, we've got gvalue here. So if you look at that first code example, it's just a simple traversal, just has label traversal. And there's this new thing in there called a gvalue. This is essentially a container around a parameter name and value. So what that's essentially saying is that in the generated script here, the query should have a parameter label passed into the has label step, and that request will have a parameter map that assigns the value person to it. I've got the example there in both Java and Python, and an equivalent will come for all the other GLVs as they're completed. This is just a nice simple syntax to indicate you want to pass a parameter for a specific value. The last piece I want to highlight here is about strategy construction and declaration. There's a few layers to this. The first piece I'll note too, and this is in the bottom example here, is we're now using what I'd like to call sort of the map style configuration. It's not actually a map, but it's sort of passing key value pairs in as the strategy arguments. And this is now the standard script syntax for configuring your strategy. So in that first one there, I've just got some arbitrary configurations. You can pass in strings, ints, whatever types you want. And that's going to be how you can pass your configurations into your strategy as you're constructing it. Another piece to note here is that there's no new keyword at the start of that. It's not with strategies new my strategy. So that new keyword is now just optional in Gremlin Lang. If you use it, it's fine, but it's not necessary. And lastly, just by it being my strategy, you'll notice two things about that is one, it's a custom strategy. So there's now support for custom strategies in here where a provider can register their strategy with the Gremlin Lang parser, and then any script that comes in with that strategy name will be able to immediately activate and configure the custom provider strategy. And also there's just a simple class name. We don't need to use the fully qualified Java class. That's proven problematic before in some of the GLVs that don't have access to Java classes. So everything just works off of the simple strategy names now instead of fully qualified Java classes. And the final piece there as well is that without strategies has now been added to Gremlin Lang, as that was previously missing. So that's everything I want to highlight on Gremlin Lang updates. Last piece I want to look at here is changes to Gremlin console. And the main piece here is that the remote and submit commands have been removed. So now instead, the proper way to submit your remote Gremlin scripts is using a remote traversal source. So there's many different ways to construct a remote traversal source. the example I've got here is just using the configuration file, which is the most similar to how you would have done a remote connect command previously. But any of the standard ways of constructing a remote traversal source are valid here. And then you just use this G as you would normally to make your Gremlin. So this just sort of simplifies things, makes it one standard way of sending your connections. You're using Gremlin the same way you'd use it in Java, say. So it just keeps everything standardized in a single path. So that's the reason for that change. And final thing I want to look at here is just what's still upcoming for TinkerPop 4. So the most obvious piece is the remaining GLVs will be converted to HTTP and added to TinkerPop 4. We've just started with Java and Python as a sort of starting point to get some feedback from users. So the remaining ones will all be coming. Secondly, one thing that hasn't made its way over from WebSockets yet is transactions. So transactions were never supported in HTTP in 3.7 or all of TinkerPop 3. We're looking at defining a new transactions API to bring that support over HTTP. Nothing's been finalized just yet, so that's going to have to come through the dev list soon, but that's on that will be coming. One more piece I want to look at is we had another contributor, Tian, rewrite the JavaScript GLV with TypeScript built in. So once HTTP comes to the JavaScript GLV, users will notice it's now all natively in TypeScript, so no longer need to rely on the definitely typed Gremlin library. And the final piece I want to mention is that considering simplifying the configuration options for the GLVs as much as possible. And what I mean by that is both a reduction of arguments, especially with the Java driver previously, there's a lot of options that most users didn't necessarily know how to tune very well. There's a lot of very low-level options there. Some of them were a little bit redundant as well. So we're looking to clean that up a bit. And also we're looking to standardize the different options across the GLVs as much as possible. They'll never be exactly the same options, as all the GLVs have different underlying HTTP libraries that they're built on top of. But as much as possible, I'd like to standardize that experience for uses of the different GLVs. So that's what's coming up for TinkerPop 4. As always, if you want a comprehensive list of all the changes that have gone to the recent beta, take a look at the changelog. I'd also highly recommend taking a look at the upgrade docs for this beta. And with that, are there any questions? Yeah, what level of Gremlin language compatibility is there between 3.x and the 4 beta? I'll take it from the context of running a Gremlin script, because obviously bytecode is gone now. So in terms of just running a script, there's quite a bit of compatibility. There's not a lot of changes to any of the step implementations themselves. Someone can jump in if you remember any steps that have changed here, but the general goal is that most of the Gremlin should execute the same as it would in TinkerPop 3. If I missed any changes in there, I don't think there's any changes to step behaviors.
I think there was like actively trying to not change the implementation of the steps.
The goal of the work, as much as possible, is always that we shouldn't be breaking and changing things for no reason. So as much as possible, changes should be pretty minimal. Users' Gremlin should be portable from 3 to 4. One thing I will note is that in 3.7, the grammar did permit parameters in all steps. Currently in the beta, those parameters are restricted to sort of steps where you kind of foresee that providers may be able to build some optimizations off of parameters. So this is mostly in places where people would be passing in like values in like a has step. So some of that's changed. That's all in the upgrade docs, but for the most part, users shouldn't notice any significant changes in how the Gremlin executes. Are there any particular challenges that providers should know about when implementing the 4.0 beta?
I would say there was like quite a few things we changed for providers, and like one of the things we talked about was removal op processor. I don't know if any provider actually used op processor, but yeah, there was a lot more changes for that. But I mean, like I would refer to the upgrade docs there, since there's a whole section for providers. But yeah, off the top of my head, there's just like things like that we've sort of changed.
How compatible is Gremlin in Groovy versus Gremlin Lang? This is something that's gotten a lot better over the years, but there are still some slight differences. Yang alluded to one of them earlier, which was that for big decimals in scripts, there's a different suffix to indicate a value should be a big decimal. So can always put, like, if you're writing a, like, let's say a float, you could 0.1f, right? That indicates that that's a float literal. That's the same in Gremlin Lang and Groovy. Big decimal is different. I believe it's an M as the suffix in Gremlin Lang, and I forget what it is in Groovy. There are different suffix there. So that's one difference. Groovy also has a few steps where if they take multiple arguments and you pass null as both of them, Groovy can have a problem where it can't disambiguate the overloaded methods, so it can throw an error, whereas Gremlin Lang generally isn't prone to that. It has a hierarchy of, it prefers one overload over the other when it's ambiguous. So there's a few minor changes, but nothing substantial for most use cases. And any other questions? Not seeing any here. So with that, thank you for joining us, everyone. Hope you have a great day. Take a look at the new beta and give us some feedback on Discord on the dev list. I'd love to hear any thoughts you have on it. All right, thanks everyone. See you in the next one.